Good morning to all. Welcome to this session. So myself G.SARANYA, working as an assistant professor in the Department of Computer Science and Engineering at S.A.E. Engineering College, Chennai. So in this GATE coaching class, today we are going to discuss about the topic programming and data structure. So today we are going to discuss few GATE questions. So under the topic stack as well as queue. So before moving to the GATE questions, we will be seeing an overview of introduction to stack, followed by basic operations on stack, followed by introduction to queue and basic operations on queue. At last we will discuss about GATE questions. Okay. So next thing is, okay. So what is stack? Stack, it follows the principle last in, first out. So consider this is a stack. So here we are going to insert few elements. For example, here we are going to insert an element 5, 50, 100. Okay. So if I want to insert an element onto the stack, now just think that I am going to insert all these elements in order. Okay. So first thing is I am going to insert an element 5 onto the stack. So I have to insert the element 5 onto the stack. So now this is the first element, right? This is the first element. And now I am going to insert another element, that is 50. And at last I am going to insert an element 100. So listen here, this is a stack concept. So which means the element that we have entered at the last, we can remove at first. That is why we are saying that is last in, first out. Which means here, the last entered element is 100. So now we can remove only the element 100 at first. Understood? So the next thing is, we can say in another word, that is first in, last out. Here, which is the first element we have inserted? 5 is the first element we have inserted onto the stack. So here we can remove this element 5 only at last. After removing this 100, 50, then only we can remove this element 5. That's why we are saying stack uses the principle, it follows the principle last in, first out, or we can say first in, last out. Okay. So what is LIFO? LIFO in the sense last in, first out, which means the element that is inserted at last we can remove at first, or it comes out first. Okay. So what is FILO? It means that the element that inserted first will come out at last only. Okay. So here, listen here, here the insertion as well as deletion can happen only at one end, which is at the top of the stack. Isn't it? Here we can insert the element only at the top of the stack and we can remove the element only at the top of the stack. That's why we are saying the insertion as well as deletion can be done only at only one end of the stack, which is the top. Clear? Okay, next. So next thing is, we will see some basic operations on stack. So there are few operations, basic operations I am going to explain here. First thing is push, pop, top is empty and is full. So push is used to insert an element onto the stack. So if you want to insert an element onto the stack, we'll say that is a push. So the removing of element, we will call it as a pop operation. And what is top? The top will return the top element of the stack. So here, which is the top element of the stack? So in this example, C is the top element of the stack. So here, if you use the top, it will return the top of the stack, that is C. Okay. So next thing is empty. What is the use of is empty? Is empty is used to check whether the stack is empty or not. If the stack is empty, it will return to true, else it will return false. So next thing is full. What's the use of is full? It is used to check whether the stack is full or not. If the stack is full, it will return true, else it will return false. Right? Okay, next we will move to the concept of queue. So what is Q? So again the Q, it uses the principle first in first out, so that we will call as FIFO, right? So what is FIFO? The element that we have inserted onto the Q first, we can remove at first, right? So here the insertion can be done at one end of the Q, that is we will call that as a rear end. So here the insertion can be done at one end, that we will call as rear end, and the deletion can be done at another end of the Q, that we will call as front end. Clear? Okay, so we will move to the next thing, that is we will see some operations on stack. So like the same way here in Q also we have few operations, basic operations. So first thing is NQ followed by DQ, and next thing is get front, get rear, is full, is empty, and size. Clear? Okay, so what is NQ? So NQ means inserting an element onto the Q, or inserting an element. So see here, as I already explained that, so here the insertion can be done only at the rear end, right? So here the insertion can be done only at the rear end. Okay, so what about this DQ? Here the DQ means removal of elements from the Q. Here the deletion of Q can be happen only at the front end. Okay, so next, get front. What is the use of get front? It is used to retrieve the front node. So I already told that here we have front end as well as rear end, right? So get front in the sense it will return, or it will acquire the data element which is available at the front, right? So what is the use of get rear? It will return the element at the rear end. So what is full? It is used to validate whether the queue is full. So what is the use of is empty? It will check whether the queue is empty. So what's the next thing? Size of. It will return the number of elements present in the queue. Clear? So next thing is, okay, now we will discuss few gate questions, okay, based on stack as well as queue. So see the first question. Consider a sequence of elements. A0 is equal to 1, A1 is equal to 5, A2 is equal to 7, A3 is equal to 8, A4 is equal to 9, and A5 is equal to 2. So the following operations are performed on the stack S and a Q, both of which are initially empty. So what they have given here, they have given a sequence of elements from A0 to A5, and what they have given, they have given few operations, only those operations we have to perform, and they have given that is, they have considered the stack as S and the Q as Q. Clear? So what they have given in addition with that, they have given both of which means both the stack as well as Q are initially empty, right? So what's the first operation? So these are the operations they have given the questions. Okay, so what's the first thing? Push the elements from A0 to A5 in that order into S. So S means stack. So what they have given, we have to push all the elements from A0 to A5 into S. What's the second thing they have given? NQ the elements of A0 to A5 in that order into Q, which means again from A0 to A5 we have to insert the elements. What is meant by NQ? We have to insert, right? So insert all the elements from A0 to A5 into the Q. What is the third thing they have given? Pop an element from S. So what is the basic operation of stack? Push and pop are the basic operations, right? So what is meant by pop? Which means we have to remove an element or delete an element from a stack, right? Okay, so always we can remove the element from the stack, only the top of the element, right? Okay, what's the next thing? What is the fourth operation they have given? DQ an element from Q. What is meant by DQ? As we already discussed, DQ in the sense remove removing an element from a queue, right? So we have to remove an element from the queue in the sense, as you all know that deletion can be performed at the front end, right? Okay, what's the next thing? Again, pop an element from yes. So again we have to pop an element from stack yes. Again, what is the sixth operation they have given? We have to dequeue an element from queue. And what is the next thing they have given? Dequeue an element from queue. And in addition with that element we have to push the same, which means what's the meaning of that? We have to push the same element onto the stack. Clear? What's the next thing they have given? Repeat operation 7 3 times, which means this operation we have to perform 3 times, right? What's the next they have given? Ninth operation, what they have asked us to do? Pop an element from yes, so which means the top of the element from the stack we have to remove. And the next thing is pop an element from yes, which means again they ask you to remove the top of the element from stack. So at last what is the question now here? The top element of yes after executing the above operation, which means after performing all these operations, now we have to check which is the top of the element. Clear? Okay, so shall we move to the solution now? Okay, so what they have given in the question? A0 is equal to 1, A1 5, A2 7, A3 8, A4 9, A5 2, and they have given stack as S and Q as Q. So what they have given, initially both stack as well as Q both are empty, right? Okay, so what's the first thing they have given? So now we can solve this, right? Oh, see here. So what's the first thing they have given? We have to push the element A0 from A0 to A5 into stack yes. So they have represented stack as yes. Clear? Okay. Next they have given, so just a minute. They have given Q as Q, right? So how will we represent the Q? Like this. Okay, consider this is a Q and this is a stack. Okay, what's the first thing they have given? So in first they have given both stack as well as queue both are empty, right? So this is, you just consider this is an empty stack and this is an empty queue. Okay, okay. Okay, so now we have to push the element from A0 to A5 in the same order, right? So what is A0? 1. So initially the this one is top pointer is -1. Now I have to insert an element 1. I can insert here, right? Okay, next what is the next element we have to insert? We have to insert an element A1, which is 5. Next, what is the next element? 7. Okay, and what is the next thing? 8 followed by 9, and what is A5? 2. So now this is the top of the stack. Clear? So this is the top of the stack, right? Okay, so we have completed the first operation. Yes, we have completed this first one, right? Okay, what's the second question they have given? What's the second operation we have to perform? NQ A0 to A5 into Q. So here what is the thing? First we have to insert 5 followed by A0 to A5 in the sense first we have to insert the element A0, next thing is A1, A2, A3, A4, and the last thing is A5. Clear? Okay, so now the second one also completed. What is the third thing they have given? So this is number 2. Yes. Okay, what's the next thing? Pop from S, which means they have given pop an element from S. So this is yes, right? So we have to pop an element from S in the sense, as we already discussed that the element can be inserted or deleted only from the top of the stack, right? So here which is the top of the element? So 2 is the topmost element. So we can remove only this 2, okay, right? So what is the third thing? So from this we are going to remove. So as it is, we have to write 7, 8, 9. So which means from this we are going to pop this element from stack, right? Okay, this is third operation. Clear? So this also completed, right? So what is the fourth operation they have given? We have to dq from q. So this is q. So from this we have to dq. So dq in the sense, this is the first element we have inserted in the q, right? So now we have to delete which element, 1 or 2? Here 1 is the first element we have inserted, right? So now we can delete only this 1. Clear? So I am going to dq this 1. So what will be the result in fourth one? So what will be the result? So we will have the element 5, 7, 8, 9 and 2. Clear? So this is the fourth operation. Okay. Now what is the fifth operation? They have given pop from S, which means again we have to, now this is yes, right? And now this is, okay, now this is yes, right? Okay. Now what they have given? We have to pop an element from yes. So which element we have to pop? Which is the topmost element? 9. So 9 we have to pop, which means what is the answer? What will come here? 1, 5, 7, 8. Clear? So this is fifth one. Clear? Okay. Now what is the next thing they have given? dq from q. Now this is q, right? Okay. So now what they have given? dq from q, which means we have to remove an element from q. So now from this, which is the first element, 5 is the first element. So what will be the result here? So what will be the result? So the result will be 7, 8, 9 and 2. This is number 6. Clear? This is number 6. Clear? Okay, what's the next thing? What's the next question they have given? Again dq from q. Yes? Okay. So dq from q, in the sense we have completed, right? And what they have said there, we have to dq from q and we have to push the same onto the stack, right? So which is here stack? This is the stack, right? So we have to insert the element. Which element we have inserted here? I have erased this, right? So initially we have 1, 5, 7, 8, 9 and 2. So what is the first thing? In the second step we have is pop from stack, dq from q. So in the fourth step we have dq this one. So remaining we have this, and in the sixth step we have dq this 5. So this is our last thing, right? So now we are going to perform this one. So dq from q and we have to insert onto the stack. So which one we have to insert? We have to insert this 7 onto the stack. Clear? Okay. What's the next thing they have given? Repeat the operation 7 3 times. So we have to repeat the same operation 3 times. Clear? Okay. What is the seventh operation? We have to dq. So now we have removed this, right? We have to dq an operation from q, right? Which means we have to remove this element from the queue and we have to insert the same onto the stack. So here which is the first element we have to remove from the stack? So we have to remove this 8. So we have to do this 3 times, right? So 8, 9, 2. Clear? So now which is the topmost element of the stack? 2. Clear? Okay. So what they have given here? Pop from yes. So what the meaning of that? We have to remove this. So what will be the answer now? 1, 5, 7, 8, 7, 8 and 9. Clear? Okay, so we have completed this. So this is the 9th one, right? So what's the last thing they have given? Again we have to pop from S, which means again we have to pop the element from the stack. So now which is the top of the element? 9 is the top of the element. So we have to remove this, right? We have to delete this element. So what will be the output? So 1, 5, 7, 8, 7 and followed by you will be getting 8, right? So this is the 10th operation, right? Okay, so now what they have asked now, top element of S. Now we have to find out which is the topmost element of the stack after performing all these operations. So now we have completed all the operations, right? So now tell me which is the topmost element of the stack. Now 8 is the topmost element. So what is the answer for this question? So for this question the answer is 8. Clear? So the answer is for this question the answer is 8. Okay, so after performing all these operation, now the topmost element of S in the sense stack is 8, right? Okay, so we'll move to the next question. So next question is, consider the following sequence of operations on an empty stack, and they have given push 54, push 52, pop, push 55, push 62 and S is equal to pop. So what they have given here, we have to perform all these operations on the stack, right? And what's the next thing they have given? So followed by we have to perform, they have given an empty queue and we have to perform all the operations on the queue. What are the operations we have to perform on the queue? NQ21, NQ24, DQ, NQ28, NQ32, and we have to store the DQ, we have to perform the DQ operation and we have to store the value in queue, right? Finally what we have to find out, we have to add the value of S with Q and that is the final answer, okay? So we will see how we have to perform this, okay? So the thing is, they have given it is an empty stack, right? So how we have to represent this stack? Just consider this is an empty stack, okay? Okay. So now, what's the next thing they have given? We have to consider an empty queue. So before moving to queue, we will be performing all the operations of the stack, okay? So what is the first thing they have given? We have to push the element 54, right? So 54 in the sense where we have to insert, we can push the element 54 here, right? So as we already discussed, insertion and deletion can be done only at the top of the. So initially it is an empty stack in the sense, now this is the top of the stack. So now we can insert the element 54 only here, right? Okay, what's the next thing they have given? Push 52, which means the element 52 again we have to insert onto the stack. So what's the next thing they have given? Next thing they have given is pop. What's the meaning of that? We have to remove an element from this stack, right? So which element we can pop from the stack? Always we can remove the top of the element from the stack, right? So now see the stack, which is the top of the stack. Now the top of the stack is 52, right? Clear? Okay. So what will be the output of this? So there will be a stack, right? So only 54 will be there. What is the reason? Since 52 is the top of the stack, we can remove only this element from the stack, right? Okay, so this operation is also completed. What is the next thing they have given? Push 55, right? So again we have to push the element 55 onto the stack. Clear? Okay, what's the next thing they have given? Again push 62, right? So we have to push the element 62. Okay, so now what they have given, pop and store that in this variable. Yes, so which element we can pop now? 62 is the top of the stack, so we can pop the element 62 and we can store in the variable yes. So 62 is the value of yes. Clear? Okay, so next we will see about the queue. Okay, we will perform the operations in the queue. Okay, So just think that this is a queue, consider this as a queue, okay? Okay. So what they have given NQ21, which means we can insert the element 21, followed by again they have given NQ24, which is 24. Okay, again now see here DQ. So what's the meaning of this? We have to delete an element from the queue. So which element we can delete? The element which we have inserted first only we can remove. So which is the first element here? 21 is the first element. So we can remove this element, right? Clear? Okay. So just think that in queue now we are having only 24. Okay, so what's the next thing they have given? Again NQ28, which means we have to insert an element 28 onto the queue, followed by again they have given in queue we have to insert an element 32. Clear? Okay, now see that what they have given here. Now what's the next operation? This is also completed, right? So what's the next operation? Q is equal to DQ. So which means we have to perform the DQ operation and then we have to insert store in a variable Q, right? So which is the element we have to remove from the queue? Since 24 is the next element we have entered in the queue, we have to remove this element from the stack, from the queue, right? So now we have to remove this element from the queue and we have to store that in the variable Q, right? So 24. So what's the value of S? S is 62 and what's the value of Q? Q is 24. So what they have asked in the question, the value of S plus Q. So what's the answer? 62 plus 24, which is 86, right? So the answer for this question is, answer for this question is 86. Clear? So 86 is the answer, right? Okay, so we'll move to the next question. So here see let S1 and S2 be two stacks and S1 has capacity of 4 elements and S2 has capacity of 2 elements. So S1 already has 4 elements and they have given the elements as 100, 200, 300 and 400, whereas they have given S2 as empty, right? Okay, this is what they have given in the question, right? So in addition with that they have given only this following 3 operations can be performed in the stack, right? See, only these 3 operations can be performed in the stack. So what are the operations? We can push to the stack S2, we can push the stack we can push to S1 and we have to generate the output. See in the first operation what they have given, push to S2 in the sense, pop the top element from S1 and we can push that on S2, which means from the element from top of the stack from S1, that is from stack S1 we have to pop the topmost element and we have to push that element onto the stack S2, right? So that is push to S2. What's the next thing they have given? Push to S1 in the sense, pop the top element from S2 and we can push on to S1. Clear? Okay, so what is the output they are expecting? Generate output, what is the output which means here, pop the top element from S1 and output to the user, which means we are going to write the output only the top of the element from the stack S1, okay? So we have to consider the stack S1 top value as the output, okay? We can generate. So what are the other conditions they have given? Note that pop operation is not allowed on empty stack and push operation is not allowed on full stack. What is the meaning of that? If a stack is empty, we can't perform pop operation, right? What is pop operation? We want to delete an element. If the element is inside only, we can delete that, right? So this is not possible, right? Okay, what's the next thing they have given? Push operation is not allowed on a full stack, which means if a stack is full, we can't insert any element onto the stack, right? So they have given this also, right? What's the next thing? we have to solve this question, right? So what they have given in addition with that, which of the following output sequences can be generated by using the above operations, right? This was a question which was asked in the GATE 2024. Okay, see, listen here, they have given 4 sequences. Now we have to check whether all these sequences are possible, or what are the sequences is possible in this. Okay, based on those all operations, they have given 3 conditions, right? So we can use only 3 conditions. Clear? Okay, so next thing is, okay, see, so given we can push to stack S2. So what is the condition? How we can push to stack to the top of the value? Only the top of the value we can see, only this top value we can push to S2, right? So that is first thing. What's the second thing they have given? Push to S1. What is the meaning of this? Again, this top value we can push to. We can pop the top of the value from S2 and we can push the value onto the stack S1. So this also they have given, right? What's another thing they have given? Generate output, that is, pop the top element from S1 and that only we can consider as an output, right? So if you want to generate an output, the thing is we have to take only this top value, right? So they have given the conditions also. So for our reference, I have written all the sequences here. So we will move from, we will check with the first option, right? Okay, so what is the first option here? So the first option is A, right? Okay, we will check this. Okay, so think that, see, the size of stack 2 is size of stack S2 is only 2, right? Size of stack 1 is 4. Okay, so maximum how many elements we can push onto stack S2? Only 2 elements, right? So we check with the first possibility, right? Okay, what's the first thing? So which means the top element we want 100 of this stack, right? Which means then only we can generate that as an output, right? So now I am going to pop this element from stack S1 to stack S2, right? Okay, so now which is the top of the element? 400. So I can pop this element. Now I am inserting, or now I am going to perform push operation on stack S2. So which means now what is the top of the element? 300 in stack S1, and now the top of the stack in S2 is 400, right? Okay, now I am checking another option whether it is possible. Now I can move this to this, right? So now, which means I can pop the element from stack S1 and I can push the element onto the stack S2, right? So now what is the top of the element on stack S1? 200, right? Okay, just think that whether any possibility to move this 200 onto stack S2? No. What is the reason? Since the size of the stack is 2 in S2, we can't insert more elements on stack S2, right? So if we print this, so this 200 only will come at first, right? So which means there is no possibility for sequence A, right? So this will not come. Right, there is no such possibility. Clear? Okay, so now we will move to the we'll check the second options, right? What is the second option? The second option is 200. Clear? Okay, so we will try with the same thing, right? Okay, now I am going to perform the operation. See, so this is the first thing, stack case 200, 300 is there. Okay, so now what I am going to do is S2, the maximum size is 2. So I can pop this element from stack S1, I can push the element onto S2. That is what we can perform here, right? So I am going to pop the element from S1. Here 400 is the top of the element, right? So I am going to pop the element from S1 and I am going to push the element 400 onto the stack S2. So this is S2, right? This is S1. Clear? So now check, we need 200 at first, right? So what is the next operation? What is the next possibility we can do? We can again push this element 300 from stack 1 and we can pop this element S1, right? What is the topmost element here? 300, right? So we can perform pop operation only at the top of the stack. Yes? So we can pop this element 300 from stack S1 and we can push the element onto the stack S2. Yes? So what will be the next step? So 100 will be here and 200. This is S1 and what will be there in S2? Here 400 and here 300. Clear? Yes? Okay. So now check this possibility. Now we can print this as an output, right? What is the condition for generating output? Pop the top element from S1 and we can generate as an output, right? So there is a possibility for 200, right? Okay. So we will check with the other possibilities, right? Okay. Okay. So now in S1 we are having, what we are having in S1? 100, right? Okay. What we are having in S2? 400 and 300. Clear? Okay. So this is S1 and this is S2. So what is the next thing we need? 300, right? Okay. So can I print this as an output? No. What is the reason? What they have given? If you want to generate it as an output, we can pop the element from stack S1, not from S2. So what is the next thing we can do? We can pop this top of the element and we can push to the stack S1, right? Okay. So what will be the output here? So 100 and 300. So this is S1 and here only 400 will be there, right? So now check whether we can print this. Yes, we can generate this as an output, right? So what will come here? 300. Clear? Okay, so now S1 having only 100 and S2 we have only 400, right? Okay, what's the next thing they have given? In a sequence 400. Whether 400 is possible? Yes, right? How it is possible? We can't print this as an output, right? So how it is possible? We have to pop this element from stack S2 and we have to push this element onto the stack S1. So what will come here? 400. We can pop this element from S2, right? So now we can print this 400 as an output, right? Okay. So now what is the next thing? In S1 only we are having 100 and S2 is an now empty stack, right? So now the top of the stack is 100, so we can print this. So this sequence is possible, right? Okay, like the same way we have to check with option C and D, okay? Shall we check option C and D? Okay. Option C here is 400, 200, 100 and 300, right? So what is the possible here? See, we are having top of the stack as 400. So what's the first thing we can do? We can pop the top of the stack from S1 and we can generate as an output, right? So I think I can directly write this, right? Okay. So what are the elements we have in S1? 100, 200 and 300, right? Okay. So what about in S2? S2 still it is empty, right? Okay. What's the next thing they have given? We have to try whether 200 is possible or not, okay? So if we pop the element from this stack S1, that is, if we pop the element 300 from S1 and if we push the element onto the stack S2, then we can directly print 200, right? So what's the first operation we can perform? We have to pop the element 300 and we have to push the element onto the stack S2, right? So what will come here? So here 300 will come, right? Now we can directly print this 200. Since this is the top of the stack, we can print this 200, right? Okay. So now what are the things we have? We have to check 100. Now again see here S1, this is the top of the stack. So we can print 100 followed by next. We have to move. So what will come here? S1 is now empty, clear? And S2 we are having 300, right? Okay, so now what we have to do? We can't directly print the top of the stack from S2, that is a condition. So we have to move this to stack S1. So now we can print this, right? So again, C also possible, right? Okay, what's the next thing? We have to check with the another option, that is D. Okay? Okay. So initially we are having like this, right? So we need, first thing is 300. So what is the first option? We can move this 400 onto the stack S2, which means we can pop the element 400 and we can push onto the stack S2, clear? Okay, so what will be the first thing? So now in S1 we will be having 100, 200 and 300, and in S2 we can, push the value, right, which is 400. So this is S2, clear? Okay. So now see, we want to print 300. Since this is the top of the element, we can directly generate that as an output, right? Okay, so 300 we can generate this as an output, so it is possible. Okay, so we can remove this, right? Okay, so now what are things we have? 200. Now we have to check whether we can print 200. Yes, since this is the top of the stack, now we can print this 200 also, right? So next, what's the next thing? So in S1 we are having 100 and S2 we are having 400. So we can't directly print 100 because the given sequence is 400 and followed by 100, right? So this 400, now we have to push onto the stack S1. Now we can print this, right? And at last 100 alone will be there in S1 and you can print this. So in this, option D is also possible, right? So what are the answers here? So the correct answer is, see, the correct answer is B, C and D, and A is not possible, right? So the correct answer is B, C and D. So we will see some more questions, gate questions in the upcoming sessions. Thank you.